Hi dear student, welcome to my channel. So in this slot we're going to discuss another type of essay question that is under to investigate the electrical conductivity of ionic and covalent compound. This is very important also for SPM under Form 4 Chapter 5 chemical bonding. Alright, so now we move on to the short essay question. Alright, state the physical properties of ionic compound. Please remember ionic compound is a formation of compound via transfer of electrons between metal plus non-metal. All right, so this ionic compound, the physical properties, they have high melting and boiling point due to the stronger electrostatic attraction force that exists between the opposite charged ion or the positive ion and negative ion. All right, so and thus more heat energy is required to overcome the forces of attraction. And this ionic compound also conduct electricity in molten and aqueous state, not in solid state. So in molten and aqueous states, the ions are able to move freely and must put this word and can conduct the electricity. All right, so most of the ionic compound is soluble in water. All right, but insoluble in organic solvent. Please remember. All right, so next we go for physical properties of covalent compound. Covalent compound is the formation of chemical bonding between non-metal atoms via sharing of valence electron. All right, so this covalent compound has low melting point and boiling point due to the weaker van der Waals forces of attraction or intermolecular forces of attraction between the molecules. All right, so thus less heat energy is required to overcome the forces of attraction and do not conduct electricity because all the covalent compound exist as molecules. There is no freely moving ions to conduct electricity. And please remember all the covalent compound, most of the covalent compound insoluble in water, do not dissolve in water, but soluble in organic solvent. And please put here except. All right, except this acid like hydrochloric acid, nitric acid, all right, sulfuric acid, or even the weak acid like CH3COOH, which is ethanoic acid, made up of covalent compound, but they are soluble in water and also soluble in organic solvent. All right, so and other than that, please remember all the halogen like chlorine, not all chlorine, bromine, and even iodine, they also soluble in water. Okay, at the same time they also soluble in organic solvent. And another one is ammonia NH3, even though it's made up of covalent compound, but this ammonia soluble in water, also soluble in organic solvent. So please remember all this. All right, so now we go for short essay question. If let's say sodium chloride can conduct, sodium chloride is made up of ionic compound. Please remember metal plus non-metal. This is made up of ionic compound. Ionic compound, the particles that exist in the compound is ion. All right, so we have three physical state. So number one, solid. Number two is molten. Number three is aqueous. So solid cannot conduct electricity. Molten and aqueous, they can conduct electricity. Why? Explain. So sodium chloride is an ionic compound. In solid state, the ions, sodium ion and chloride ion, are held together by stronger electrostatic attraction forces. All right, and they are arranged in lattice structure. The ions are fixed at the position and do not move freely. In ionic compound in solid state do not conduct electricity. In aqueous state, the sodium ion and chloride ion, or the ions, are able to move freely, therefore they can conduct electricity. Please remember this point. I already discussed a few examples of question in previous video. Please check. All right, next one. We check here, they give one covalent compound, another one is one is ionic compound, another one is covalent compound. So this is lead-2 bromide, and here they put molten, so we have lead-2 ion and bromide ion. This ion able to move freely. All right, freely move and able to conduct electricity. So please remember, able to conduct electricity. And molten naphthalene C10H8, they exist as molecule. They are made up of covalent compound or covalent bond. All right, so they do not have freely moving ions to conduct electricity. So how to explain the we check the question. Explain why molten lead-2 bromide conduct electricity while molten naphthalene do not conduct electricity. Lead-2 bromide are made up of ionic compound and exist as ion. In molten state, the lead-2 ion and bromide ion able to move freely and conduct electricity. Naphthalene. All right, so we can put therefore the ammeter needle deflects, all right, and shows reading. All right, so next one, naphthalene. Okay, is a covalent compound and made up of covalent molecule. In molten state, there is no freely moving ions to conduct electricity. Therefore, naphthalene does not conduct electricity in solid and in liquid state. So thus the ammeter needle do not deflects. There is no ammeter reading. All right, so please remember all this one. All right, we move on to the first question: formation of covalent ionic bonding. All right, so if the formation of ionic bonding, so this one also I already discussed in previous video. Please check right how to do this all this formation of ionic compound. I go to first question. Please check this question. All right, we try to do one question. Alright, so please read this question. Alright, a student wants to determine a type of compound U and compound V from the information analysis of the following element. So they give element X. It has three shell. It has three shells. So I put here 1, 2, 3. So here element X. It has from group 1. So it's from group 1. Alright, so that means here 1, 2. So here 8. Alright, so then the valence shell got one valence electron, therefore element X is 2.8.1. It's from sodium atom from group 1. Alright, we check the element Y. It has two shells, so I go for first shell, second shell, I put Y here. Alright, it has 4 valence electron, group 14. Please remember, group 14 has 4 valence electron. So I put here valence electron 1, 2, 3, 4. The first shell got 2 electron. That means element Y is 2.4. Alright, 2.4 will be carbon atom. Alright, so next one we try to do element Z. Okay, element Z has 3 shells. So I put here first shell, second shell, and valence shell. It has from group 17. Please remember group 17 has valence electron of 7. Alright, so I put here valence electron of 7. Alright, so 1, 2, 3, 4, 5, 6, 7. So first shell 2 electron, second shell 8 electron. Alright, valence shell is 7 electron. So this is 2.8.7. So this is chloride atom. Alright, so now we try to answer the question. So here 2 marks is given. Alright, so we try to read the question. Alright, compound V, U and V have the following physical properties. The melting and boiling point of compound U is higher, whereas V is lower. That means compound U is known as ionic compound. Alright, so we choose 2 elements from ionic compound. I choose sodium and chloride. Alright, so they want what? Choose 2 elements in the formation of for information analysis that can form the compound. Alright, so this one I choose element X and element Z. So 1 mark. Alright, so next one we check only this one, compound B. Compound B is covalent compound. So we choose 1 element from covalent compound. We choose 1 non-metal. So I choose Z, Y and Z. So I put here element Y and element Z. Alright, so please remember alright, 2.4. The valence electron of 4 indicate this element is non-metal. Alright, so the valence electron of 7 is also non-metal. So non-metal, they will form covalent compound. Alright, so please check this one. So I already scored 2 marks. Okay, now we go for another question, another type of formation of covalent ionic compound and covalent compound. Please read this question. Alright, based on the element chosen in question 11A1, explain the formation of compound U. Compound U, we already know this is ionic compound. And compound V, this is known as covalent compound. So in your explanation must include the diagram to show the arrangement of the electron in the compound U. So how to answer this one? So I check compound U is made up of element X and element Z. So I gather all the information. So here I put element X is 2.8.1. So I put here element Z is 2. Alright, so 2.8.7. Alright, so this is metal. Alright, this is non-metal. So they will form ionic compound. So these are the information that we need. So I put here formation of compound U. Alright, so first point. So I can put element X combine with element Z form ionic compound. Alright, so I talk about element X first. So element X, so I put here element or X atom. So I put here X atom. Alright, so with electron arrangement or electron configuration, electron arrangement of 2.8.1. Alright, will do what? Will donate. Please put this word donate 1 valence electron. Alright, and will do what? And achieve. Alright, achieve stable octet electron arrangement. Alright, so stable octet electron arrangement. Next point we put here positive ion of X positive is formed. Alright, All right, I go for element Z 2.8.7. Please remember, so I put here Z atom with electron arrangement of 2.8.7 will do what? Will receive one electron from X atom and achieve stable octet electron arrangement. So we already get 1 mark here. So next point, negative ion of Z negative is formed. All right, so we already get another mark. So next point, positive ion of X positive and negative ion of Z negative will be attracted together by stronger electrostatic attraction forces. All right, so I put here forces form what? So here we already mentioned ionic compound, so here I try to put form ionic bond. All right, and please remember how to put the formula. So here X will form 2.8.1, so it will form cation ion. Please remember, when valence electron 1, it will form cation ion. So I put here X positive. The electron arrangement of this ion is 2.8. So Y Z, it has 2.8.7. So the electron will be transferred to the Z atom. So here Z will form when electron, please remember, is a negative charge. So one electron move here, so we put negative. So 2.8.7 plus 1. All right, so we put here 2.8.7 plus 1, so it will gain except 1 electron. So here only form ionic bonding. So we already have X positive and Z negative. How to do the electron arrangement? Cancel. All right, so we put here form ionic bonding with the formula. Don't forget to write the formula of X Z. So we already get another mark. So we go for the electron arrangement of compound. So what is the compound? Please check here the compound U, the electron arrangement of compound U. All right, so only double dot. All right, the electron arrangement of compound U. So I put here X positive, so 2.8. So we put here Z negative 2.8.8. All right, so this is the one. So once we get the formula XZ, so we open bracket. So we put here X first shell, second shell. So first shell 2 electron. All right, 2 electron. Second shell 8 electron. All right, so we close the bracket, we take the charge, we put here. All right, so next will be Z. All right, Z got 3 shells. So first shell, second shell, third shell. So we close the bracket, we put the charge negative here. All right, so then we use a different symbol. So here 1, 2, here 8. All right, so 8. So here got 7. All right, it accept how many electron? Check here. So 1 negative, so put 1 dot here. So this is the electron arrangement, and this is the format of answer that student should write in the exam. All right, so please go through this one. All right, do more question. All right, we move on to the next question. To do the Y atom, so I put here Y atom, the electron configuration is 2.4. The Z atom will be the electron configuration 2.8.7. So I put here Y 2.84. So Z is 2.8.7. All right, so please try to ask question, how many electron needed to achieve octet. So here we have 4 valence electron. It need 4 more valence electron to achieve 8 octet. All right, Z need 1 more valence electron to achieve octet. All right, then we do crossing. All right, we bring 1 here, 4 here. So the formula, please remember, the formula will be YZ form. All right, and please highlight this one. All right, so please check Y atom will contribute 4 valence electron for sharing. All right, Z atom will contribute 1 valence electron for sharing. All right, and please circle this one. All right, please circle this one. So this one, please put inside the sharing valence shell. All right, between the atom Z and atom Y. And this one, circle this one outside. Outside we have to put what? 7 minus 1. 7 minus 1, we have to put 6. All right, so how to draw the electron arrangement of this compound? Please check the formula. So Y, we have 2.4. So first shell, second shell. First shell I fill up with 2 electron. All right, the valence shell, we check here, it contribute all 4 valence electron for sharing, so no need to put anything. Then we check the Y atom. We have total formula, check the formula, we have total 4 Z atoms, so 1, 2, all right, 3, 4. All right, first shell, second shell, and the valence shell. First shell, second shell, the valence shell put inside. All right, so first shell, second shell, and the valence shell I put inside. Alright, so here first shell, second valence shell we put inside. Alright, and Z atom, please check. Alright, the electron arrangement of Z atom will be 2.8.7. So I fill up first shell and second shell. So I fill up with this one. Alright, our first shell is 2 electron, second shell 8 electron. Alright, that's how we draw the first shell and second shell of Z atom. Alright, now we check here. Alright, Z atom inside put 1, inside put 1, Z atom inside put 1, Z atom inside put 1, inside put 1, inside put 1. Alright, outside 7 minus 1, 6. So outside I put 6. 1, 2, 3, 4, 5, 6. Alright, so 1, 2, 3, 4, 5, 6. So here I put 1, 2, 3, 4, 5, 6. So here 1, 2, 3, 4, 5, 6. Alright, if let's say Y Z atom contribute 1, Y electron will contribute 1 electron. Mutual sharing. So they will share, Y atom will share 4 pairs of valence electron. This is the drawing that students should write. Alright, we move on to the how to answer this question. Alright, so answer essay question. So I put here formation of compound. Formation of compound V. The first point will be Y atom. Y atom as electron. Electron arrangement. Electron arrangement of 2.4 and needs. It needs how many electron? We check here. It needs 4 electron. Alright, so it needs 4 electrons. So I put here it needs 4 electrons. Electrons to achieve what? To achieve stable octet electron arrangement. Now we move on to the Z atom. So I put here Z atom as electron arrangement of 2.8.7 and it need one electron to achieve stable octet electron arrangement. All right, point number 3. Point number 3, one Y atom will contribute. We already discussed, see the diagram just now, 4 valence electrons. So I put here 4 valence electrons to 4 one Z atoms. So I put here Z atoms. Next point, please check the formula Y Z4. So take the 4, put here. Alright, so we put here 4 Z atom. 4 Z atoms will contribute. Alright, 1 valence electron. We must put each. Okay, each to Y atom. Next point, one Y atom will share. Alright, so we'll share, we check how many pairs. So here we have 1 pair, 2 pair, 3 pairs, and 4 pairs. So we'll share 4 pairs of valence electrons with how many Z atom? With 4 Z atoms and form. Alright, form what type of bonding? So we check the sharing shell here got 2, 2, 2, 2. That means they form 4 single covalent bond. Please remember they will form 4 single covalent bond. So this is the one, 4 single covalent bond. So I put here form 4 single covalent bond. Alright, so next point, Y atom and all the Z atoms have achieved what type of arrangement? Achieve stable octet electron arrangement. Alright, so next point, covalent compound. Covalent compound. So here I already mentioned covalent, single covalent bond. So here we put covalent compound with formula. Don't forget to write the formula. Formula of YZ4 is formed. Alright, then we draw the arrangement of the compound. We take this one. Alright, we draw here. Alright, so we move on to the next question. Just now we discussed the essay question about CCl4, the formation of CCl4. This is a CCl4 covalent compound. I already discussed just now one example of essay. So here I already have the answers in the module and how to draw, already discussed in previous video also. Now we move on to the very important essay question. Please try to practice on the formation of triple covalent bond. So please remember, triple covalent bond will be nitrogen molecule. How to explain the essay question is here, and I already discussed in previous video also. Alright, so please check all this one. Please go through before your exam. Alright, we move on to the formation of dative bonding. So please remember, dative bonding is a special type of covalent bond where the share pair of electrons comes from only one atom. So this is known as a special covalent bond. Alright, so where the shared pair of valence electrons. Alright, so I put here valence electrons comes, alright, comes from, alright, one atom only. Alright, so this atom contains lone pair or unshared pair of valence electron. Alright, so example of atom will be nitrogen and also oxygen, oxide atom and nitrogen atom. And please remember dative bonding, two example of dative bonding. Please remember ammonium ion and one more hydroxonium ion. Alright, so how to explain? So I already explained the formation of dative bonding in ammonium ion. So this is known as NH4 positive. Alright, so how to explain? Please check this one also. I already discussed, but I discuss again. Ammonia molecule consisting of nitrogen atom and also atom that achieve stable octet electron arrangement. So I put here nitrogen. Alright, nitrogen is 72.5 in the formation of ammonia molecule. So please remember ammonia molecule. So I draw the arrangement of atom in ammonia molecule. So nitrogen first shell, second shell. The first shell contains 2 electron. Alright, so valence shell. So here we have a ammonia hydrogen, 3 hydrogen. So 1, 2, 3. So this is the formation. So I put here, I draw, and nitrogen atom has 5 valence electron. Alright, so here hydrogen atom, alright, will contribute 1 electron for sharing. So hydrogen atom will contribute 1 electron for sharing. So nitrogen will contribute 1. So they shares 3 pairs of valence electron, form 3 single covalent bond, and nitrogen atom has one lone pair of valence electron. Please remember, or unshared pair of valence electron. This one pair of lone pair of electron or unshared pair of electron can contribute for the ion, hydrogen ion. Please remember, hydrogen ion do not have electron in the shell, and it need 2 more electron to achieve stable duplet electron arrangement. So the formation of dative bonding can be explained here. Alright, so we check again. Ammonia molecule consisting of nitrogen atom that achieve stable octet electron arrangement 2, 4, 6, 8. Alright, so octet electron arrangement, and 3 hydrogen atom that achieve stable duplet electron arrangement respectively through formation of covalent bond. Nitrogen atom has 1 unshared pair of valence electron that we call lone pair. Hydrogen ion do not have electrons in the shell and need 2 more electron to achieve stable duplet electron arrangement. Thus, the unshared pair of valence electron of nitrogen atom that do not involve in the formation of covalent bond in ammonia molecule will be shared with hydrogen ion through formation of dative bonding. Thus, ammonium ion with the formula of NH4 is positive is formed. In ammonium ion, nitrogen atoms and all hydrogen atoms has achieved stable octet and duplet electron arrangement. So therefore, Lewis dot structure. So we already draw Lewis dot structure. If student don't want to draw this, student can draw one more also. So I draw here. Alright, student can draw open bracket, close bracket. So we draw the ammonium ion. So I put here nitrogen atom. It has 2 shell. Alright, so this is hydrogen atom, hydrogen atom, hydrogen atom. This is the formation of ammonium molecule. So here we have a first shell, 2 electron. Alright, so nitrogen contribute 1 electron for sharing. Hydrogen atom contribute 1 for sharing. So this is the formation of ammonia molecules. Then we can draw one more hydrogen ion here, it will share the lone pair of nitrogen atom through the formation of dative bonding. Then we put here plus. Okay, so this is ammonium ion. We can draw this one also, or we can draw this one. All right, please practice for hydroxonium ion. All right, so this is the answer essay question if let's say dative bonding is came out in the exam. All right, now we move on to the formation of hydrogen bonding. Hydrogen bonding is the type of bonding that form between the dipole molecule, the hydrogen atom. Okay, partially positive. All right, attracted by the partially negative, more electronegative atom. More electronegative atom is FON. Alright, so more electronegative atom is known as phone. Attracted to more electronegative atoms such as FON. F stand for fluoride atom, O stand for oxide atom, N stand for nitrogen atom. Alright, so we try to answer this question. So please remember in the module got alright, so we go for formation of hydrogen bonding can explain by using water molecule. Oxide atom in water molecule. Okay, as is a highly electronegative atom. Water molecule consisting of two hydrogen atom that share one pair of valence electron each with a highly electronegative oxide atom through formation of covalent bonding. Alright, so the electron pair that shared between hydrogen atom and oxide atom will be pulled towards oxide atom because oxide atom is more electronegative atom. Thus, hydrogen atom become partial positive charge while oxide atom become partial negative charge, and thus water molecule become a dipole molecule. The attraction forces between hydrogen atom and oxide atom with nearby water molecule form hydrogen bonding. So please remember all this and try to do for ammonia molecule also. There's a formation of hydrogen bonding between hydrogen atom and nitrogen atom of nearby molecule in ammonia molecule also can be used to explain in essay question. So please practice this one. We move on to the next question. All right, we move on to the next question. Question number 10, formation of metallic bonding. All right, formation of metallic bonding occur between the metal that exists in solid form. All right, so here the attraction forces. So the attraction forces will be electrostatic forces of attraction between the metal ions and the sea of electrons that form through the delocalized electron is will form metallic bonding. So we try to check the formation of metallic bonding. The formation of metallic bonding can explain by using sodium metal. So sodium atom as electron arrangement of 2.8.1 and exists as solid at sodium atom in solid state are arranged closely packed in lactic structure. So sodium atom can only vibrate and rotate at the fixed position. During vibration and rotation, some of the valence electron of sodium atom can be delocalized. The delocalized electron form sea of electron and sodium atom form positive ion. The attraction forces, or we can put the electrostatic attraction forces between the sea of electron and positively charged sodium ion form metallic bonding. So this how we explain the metallic bonding. We try to check one question, example of question. Look at this question. Alright, we try to read this question. Diagram 8.1 shows the mini project produced by a group of student. Electrical wires are made up of metal. So here the metal, they exist in solid state. Alright, so we move on to the explain the meaning of delocalized electron. So we go for delocalized electron. So the question 1 will be, so how to answer delocalized. Alright, so we go for delocalized electron. Electron is the electron that move. Alright, move freely and not by owned by any metal atom or any ion. So owned by any atoms nor ions. Alright, so this is the answer we should write. The delocalized electron is the electron that move freely and not owned by any atoms or any ion. The point number 2 will be sea of electrons. Electrons is formed. Alright, the sea of electrons form when the valence shell of metal atoms overlap resulting in the electron delocalization. So these are the answers that students should write here. All right, we go through again. So delocalized electron is the electron that move freely and not owned by any atoms nor ion. The sea of electrons is formed when the valence shell of metal atom overlap, resulting in the electron delocalization. We go for question number 2. Why can metal conduct electricity? Give a evidence for the your answer. So we need to explain the formation. All right, formation of metallic bonding. All right, so metallic bonding in the metal. All right, so I go for first point, metal. So this is question number 2. Metal atoms. Atoms are arranged closely packed and in order. All right, so this is the first point. All right, so maybe we can put in solid state. All right, I go for point number 2. The metal atoms vibrate and rotate at fixed position. All right, I go for third point. All right, during vibration and rotation of metal atoms in solid state, the valence electrons of metal atoms can be donated and delocalized. All right, so we go for point number 4. We go for the metal ions, okay, that are positively charged are formed when the valence electrons are delocalized. All right, we go for point number 5. All right, point number 5, all the delocalized. All right, all the delocalized valence electrons can move freely between the metal structure, or between the metal structure that form in solid state and forms sea of electrons. All right, so last point, we go for the electrostatic forces of attraction between the metal ions and the sea of electrons. All right, forms metallic bonding. All right, next point, thus metal can conduct electricity in solid state. All right, I read all the questions or answers for the question that number 2. All right, metal atoms are arranged closely packed in order in solid state. The metal atoms vibrate and rotate at a fixed position. During vibration and rotation of metal atom in solid state, the valence electron of metal atoms can be donated and delocalized. The metal ion that are positively charged are formed when the valence electron are delocalized. All the delocalized valence electron can move freely between the metal structure and form sea of electron. The electrostatic forces of attraction between the metal ion and the sea of electrons forms metallic bonding. Thus, the metal can conduct electricity in solid state. All right, we move on to the next question. Draw a label diagram. Draw and label the formation of metallic bonding. So I do question number 3 here. All right, so I draw a metal atom in solid state. They are arranged closely packed and in order. All right, so during the vibration, some of the metal atom turns into positive ion. All right, so here the electron has been delocalized. I use different color, delocalized. All right, so here we put positively charged metal ion. So this is metal atoms. All right, metal atom, and this is known as valence electron. All right, so we put valence electron. All right, so I draw again the metal atom. All right, so this is positively charged ion. All right, so they will form so sea of electrons. So we draw like this. All right, so now we label this one, all right, positively charged metal ions. All right, so this one we label sea of electrons. All right, so these are the structure that student have to draw in the exam. If let's say it came out this question, all right, please go through all these questions. So we move on to the next question. All right, please check all these. All right, so I already discussed in previous video. All right, state the three factors that affect the strength of metallic bonding: number of protons, okay, number of delocalized electron per atom, the size of ion. All right, why magnesium atom has stronger metallic bonding compared to sodium atom? So answer is given. Draw the electron arrangement of carbon dioxide. All right, please remember carbon dioxide at 2 F2 double covalent bond. So how to draw already discussed. State the function of hydrogen bonding. We can flip the pages or bank notes, okay, currency notes easily by using wet finger. So how to answer is here. All right, we move on to the essay question. To look at question number experiment, we try to go for experiment. This one can come out in section C, question number 11. The electrical conductivity of ionic and covalent compound. Experiment to determine the electrical conductivity of ionic and covalent compound. All right, so please remember this is known as ionic compound. The particles exist here is ion, so this is molecule, so therefore this is covalent compound. Example of ionic compound, please remember sodium chloride solution. All right, so here example of covalent compound, we can take glucose solution or naphthalene or ethanol solution. All right, so we try to check the question. Describe an experiment to differentiate the electrical conductivity of compound P, ionic compound, and compound Q. Example of compound P and Q, procedure, observation, and conclusion. All right, we try to check this question. The compound P, I take sodium chloride solution. Compound Q, I take glucose solution. All right, material that needed is sodium chloride solution, glucose solution. All right, so and apparatus that needed: beaker, carbon electrode, connecting wire, battery, switch, and bulb. All right, so we will do this experiment. We will take two carbon electrode. All right, so two carbon electrode we connected to the switch. All right, so here I put bulb. All right, so the carbon electrode. All right, so we pour sodium chloride solution. Once we pour sodium chloride solution and turn on the switch, the bulb will light up, and we will replace this one with glucose solution. So I replace with glucose solution. Please remember glucose solution is C6H12O6 is a covalent compound, therefore the bulb do not light up. All right, so we repeat the experiment with glucose solution. So how to answer this question? So we do the pour sodium chloride solution procedure. Pour sodium chloride solution into beaker, connect two carbon electrode to battery, switch, bulb using connecting wire. Dip the carbon electrode into beaker containing sodium chloride solution. Turn on the switch, observe and record if the bulb is lights up. Repeat step 1 until step 4 using glucose solution to replace sodium chloride solution. All right, so observation. So we go for type of compound, sodium chloride solution. Observation, the bulb lights up. Glucose solution, the bulb do not lights up. So compound P conduct electricity in molten and aqueous state, okay, while compound Q do not conduct electricity in any state. All right, try to look at this question. We try to check this question. All right, so diagram 8.2 shows the conversation between two students about the observation for the different properties in the properties of compound between substance X and also substance Y. All right, substance X shows the bulb lights up in molten state but do not in solid state. Substance Y shows the bulb do not or is not lights up in all the state. By using example of substance, using the substance example in diagram 8.2, describe an experiment to prove the statement above. So I go for substance. So I put here example of substance. All right, substance X, I take lead to bromide. Then I go for example of substance Y, I take naphthalene. All right, naphthalene. So here we have to describe in molten and also in solid state. All right, so the electrical conductivity. So the diagram that we should draw here, we take a crucible. All right, we take a crucible, so we put on the top of on the tripod stand. So here I take a carbon electrode connected to the batteries switch. All right, so here I put bulb. All right, so I take the solid here powder, lead to bromide. So bromide, so I take solid, so better to take powder. All right, so powder, then we check the bulb do not lights up. All right, so after that we heated the powder solid until it melt and form molten. Then we can see the bulb lights up. All right, then we repeat the step by replacing lead to bromide with naphthalene. All right, so this is the experiment that we should write in the procedure. So I go for procedure number one. Fill a crucible with lead to bromide powder until it is half full. All right, number two. Point number two. So we do what? Put the crucible with its content on the tripod stand and point number three, connect two carbon electrodes, okay, to batteries comma switch and bulb using connecting wire. All right, point number four, dip the two carbon electrodes into crucible containing we put here lead to bromide powder. All right, so point number five, we do what? Turn on the switch. All right, switch. And next point, observe and record the condition of bulb. All right, and point number six. All right, point number six, eat the lead to bromide. So please put lead to bromide strongly until it's melt. All right, so point number seven, observe and record the condition of bulb. All right, so and last point number eight. Point number eight, we put repeat step one until step seven by using naphthalene powder to replace lead to bromide powder. So these are the procedure that students should write in the exam if let's say this type of question came out. And next one, we go for result or observation. All right, so result be present in a table form. So I do a table. All right, I do a table. So here I put compound. All right, so here I put physical state. Then here I put condition of bulb. All right, so we have two compound. Number one is known as lead to bromide, formula PbBr2. So we have two condition. Number one is known as solid, number two is known as molten. All right, and next one we have a naphthalene. All right, so here we put naphthalene C10H will be 8, and we have two condition also. So here, all right, so here will be solid, here will be molten. And please remember, ionic compound can conduct electricity in molten and aqueous state, not solid state. So solid, here the bulb do not lights up. All right, so here the bulb lights up. All right, so here the bulb do not lights up. Compound exists as molecules. There is no freely moving ion to conduct electricity. So here the bulb do not lights up. All right, so please remember, so this is the observation or result that students should write. And last point, we check the requirement of the question. Last point, they want the conclusion. So I do the conclusion here. So the conclusion will be we put here lead to bromide can conduct electricity in the molten state, but not in the solid state. All right, solid state. All right, next point, we go for naphthalene. So I go for naphthalene. Naphthalene does not conduct electricity in all state. Alright, so please remember this experiment, two type of experiment. Here I use solution. Alright, so here we discuss for the molten state and the experiment setup also. This experiment setup no need to draw. Alright, so please remember all the format. Dear students, since this is my last slot, so I'm going to discuss another four more essay question that experimental essay question that student must remember also. Okay, if got time means please study determining the empirical formula of magnesium oxide to determine the hardness of alloy and pure metal, and very important, this one I already discussed under chapter 5 to investigate the cleaning action of soap and detergent, and one more, vulcanization, elasticity of vulcanized rubber. All right, so we move on to the first one. All right, to determine the empirical formula of magnesium oxide, please remember magnesium react with oxygen, so we will get magnesium oxide. Balance the equation, balance the oxide, so magnesium 2, magnesium 2. Alright, so we how to determine the empirical formula of magnesium oxide. Describe how to determine the empirical formula of magnesium oxide in laboratory. Include chemical equation and also calculation. So we take the apparatus, crucible, lead, 5-pot stand, Bunsen burner, clay pipe triangle, electronic balance, and tong. Alright, a magnesium ribbon about 20 cm in length, and oxygen and sandpaper. So we draw the apparatus setup. No need exam paper, answer paper. So we draw crucible. Alright, we put the clay pipe triangle. Alright, so we put clay pipe triangle and we put on the tripod stand. Only we heated here magnesium ribbon. The magnesium ribbon must clean with sandpaper. So this is crucible. This is lead with magnesium ribbon. Alright, how to answer this question procedure. So clean 20 cm power 3 of length of magnesium ribbon with sandpaper. Roll the magnesium ribbon to form a loose coil. Wait and record the empty crucible and its lid. Place the rolled magnesium ribbon in the crucible. Wait and record the mass of the crucible with rolled magnesium. Heat the magnesium. Please put this word strongly. Lift the lid. Okay, the lid. Alright, at interval of time to allow the oxygen from the air to enter inside the crucible. When magnesium ribbon is completely burned, wait and record the crucible with its content. Repeat the process of heating, cooling, and weighing until a constant mass of magnesium oxide is obtained. Alright, so how to do the calculation: mass of crucible plus lead, put A; mass of crucible plus lead plus magnesium, put B; mass of crucible, lead, magnesium oxide, put C. Alright, so and how to determine the empirical formula mass of magnesium use. So we take a B. Alright, so how to do this one? So we take the crucible, cut, lead, cut. So we have this. So we take the B minus with A or X oxide atom. Alright, how to find the mass of oxide atom? So here, mass of oxygen that combined with magnesium. So we cut the crucible, lead, cut, magnesium, cut. So we have oxide. So we take the B, C minus with B. So we put here, find the number of mole mass over molar mass. Then find the ratio, put here, and the formula like this. Write down the chemical equation as the requirement of the question. So we write like this. So this experiment, please go through. Alright, and next one, to determine the hardness of alloy and pure metal. Alright, hardness of alloy and pure metal. So we take alloy. Alright, please remember we can take bronze. Alright, and or we can take brass. Alright, the main element here, copper. We take the Zn. We take here tin. Alright, we switch the place. So we put here. This one we put here. Alright, so please remember. Alright, so we try to check the question requirement question. They want the label diagram, so we draw this diagram. Alright, and procedure: a steel ball bearing is taped onto the copper block. A meter ruler is clamped vertically, so we clamp vertically like this. 1 kg weight is hung on the retort stand. Alright, at above 50 cm length or above the surface of copper block. The weight is dropped onto the steel ball bearing. Alright, the diameter of dent formed on the surface of copper block is measured and recorded. Okay, step 1 until step 5 is repeated twice on the different surface, okay, of the same copper block. Alright, step 1 until step 6 repeated by replacing copper block with a bronze block. Alright, so we take copper block. Copper block is a pure copper block, is contain copper atoms, only one atom. Bronze contain copper. When we see Z, we change to zinc like this. Alright, so we change zinc with tin. So here we have tin. Alright, so average diameter of dent form is smaller. So here average diameter of dent form is bigger. Conclusion: average diameter of dent form on bronze block is smaller than the average diameter of dent form on copper block. Therefore, bronze is harder than copper. Alright, we move on to the next question. Alright, this one I already discussed in previous video, please check also. The cleaning action or agent A effective in art water. Please remember art water contains high concentration of calcium ion and magnesium ion. Alright, so N ion of soap. Alright, N ion of soap will combine with magnesium ion or calcium ion and form insoluble salt, and this is known as scum. Please remember. Alright, so the number of N ion of soap will reduce, so therefore they become less effective in in removing the dirt. Alright, and how to answer this one? By referring to the above statement, describe an experiment to study the effectiveness in action of cleaning agent A and cleaning agent B. So example A, B, material, apparatus, procedure, all that. Alright, so A effective, so A will be detergent. Alright, B is not effective, so B will be soap. Alright, so how to answer this one? Please check here. Cleaning agent A will be detergent, B will be soap. Okay, soap solution, detergent solution, 2 pieces of oily stained cloth, magnesium sulfate solution. So we can take magnesium, don't take calcium sulfate, because this calcium sulfate is known as insoluble salt. Alright, so please take soluble salt, magnesium sulfate solution. Alright, please check the previous video. I already discussed this one. So beaker, measuring cylinder, so please go through everything. Alright, so we move on to the last question, last essay question. This one also I already discussed under chapter 4 polymer. Alright, so please check to determine the elasticity of vulcanized rubber and unvulcanized rubber. State the meaning of vulcanization process. Process is a process to form cross-link between the polymer chain of rubber. What type of cross-link? Sulfur cross-link. Alright, please remember. Alright, so to produce rubber that are more elastic, better quality than the natural rubber. Describe an experiment to investigate the vulcanized and natural rubber. Elasticity of vulcanized and natural rubber. Diagram, procedure, observation, and draw the formation of cross-link. Alright, so please check this one. So the diagram, so we take the meter ruler, we take bulldog clip, vulcanized, unvulcanized rubber. Please remember this is natural rubber. Alright, so this is vulcanized rubber. So we hang weight at the end of one of the clip. Alright, so and we try to do the procedure, measure and cut vulcanized rubber and natural rubber strip about 10 cm length. Record the initial length of the rubber strip, vulcanized rubber and also natural rubber strip. Clamp both rubber strip on the retort stand using clip. Alright, hang 50 gram of weight at the end of the both rubber strip. Measure and record the length of rubber strip when it is stretched. Remove the weight and record the length of both rubber strip. So they want observation here. So the observation, vulcanized rubber can return to its original length after 50 gram of weight is removed, while natural rubber does not return to its original length after the weight is removed. Vulcanized rubber is more elastic than unvulcanized rubber. Alright, so how to draw this one? So this is a sulfur cross-link that form in the vulcanized rubber. So we can put here vulcanized rubber. Alright, so that's how we draw all the answer the question. Alright, that's all from me. Alright, this is the last slot. Alright, so I wish you good luck in your SPM. Alright, do the best, give the best, and make your parents really proud of you. Thank you very much. Take care. Bye bye. See you all.